Lesson 26, Inequalities in Two Triangles. The objective of this lesson is to apply inequalities in two triangles. In the last lesson, we used them for one triangle. For this lesson, you need to know two theorems, the hinge theorem and its converse. The hinge theorem states that if we have two triangles and two sides of them of each are congruent to each other, but that the included angles are not congruent, then the larger third side is going to be across from the larger included angle. So you see from the picture that since the measure of angle A is larger than the measure of angle D, BC is greater than EF. Conversely, if we know that two sides of two triangles are congruent but their angles, the included is not, then the larger angle will be across from the larger side. So in this case, we're told that GH is greater than KL. From the converse of the hinge theorem, we then can say that measure of angle J is greater than measure of angle M. Let's look at an example. We're comparing the measure of BAC to the measure of DAC in these two triangles. The first thing we want to do is compare the lengths in ABC and ADC. So we know that AB is congruent to AD because they're both 4. AC is certainly equal to itself, but BC is greater than DC. By the converse of the hinge theorem, then, the measure of angle BAC is greater than the measure of DAC. Let's look at another one. We'll compare EF and FG. First, we're going to compare the sides and angles in the two triangles, EFH and GFH. The measure of GHF is equal to 98 degrees because we take 180 and subtract the 82 because these make a linear pair. And we know that EH and GH are the same. They're both 7. FH is equal to itself. The measure, though, of EHF is smaller than GHF. So by the hinge theorem, EF is smaller than GF. One more example of this. We want to find the range of values for K. K could be more than one number. So step 1, we're going to compare the side lengths in triangle MLN and PLN. We know that LN is equal to itself, LM equals LP, and MN is greater than PN. By the converse of the hinge theorem, the measure of MLN is greater than PLN, since it's across from the larger side. So let's substitute the given values. We have 5K minus 12 is less than 38. We're going to add 12 to both sides and then divide by 5, and we get that K is less than 10. So step 2, since PLN is in a triangle, measure of PLN is greater than 0. This is because of the protractor triangle values. So let's substitute the given values. 5K minus 12 is greater than 0. Add 12 and then divide by 5. So K is less than 2.4. Step 3, we're going to combine the two inequalities, the one we got from step 1 and step 2, and we get the range of values for K is 2.4 is less than K, which is less than 10. So K must be between those two numbers. Let's look at a travel application. John and Luke leave school at the same time. John rides his bike 3 blocks west, then 4 blocks north. Luke rides 4 blocks east, then 3 blocks at the bearing of north 10 degrees east. Who is farther from the school? And we need to explain. The distances of 3 blocks and 4 blocks are the same in both triangles. The angle that's formed by John's route, 90 degrees, is smaller than the angle formed by Luke's route, which is 100 degrees. So Luke is farther from the school than John by the hinge theorem. Since this is 100 degrees, this is 90, this distance is longer than this one. Let's look at another example. We want to write a 2-column proof given that AB is congruent to CD and the measure of ABD is greater than the measure of CDB. We want to prove that AB is greater than CB. That should be AD. So our statements: AB is congruent to CD, and the measure of angle ABD is greater than the measure of CDB. This is given. BD is congruent to itself by the reflexive property of congruence. So AD is greater than CB by the hinge theorem. Now you give it a try. There's 2 slides.